Hello, folks. Welcome to Rational Science, directly from Frankfurt, Germany, the only site on the internet that does physics. Everybody else does mathematics. They do the movement of concepts. Got a message there from YouTube. I'm wondering, I hope everybody can see me and hear me okay. Okay. And let me know otherwise. Okay. Anyways, we got a great day today. We're going to be doing a little bit of this. This is the rundown. We're going to look at the electric universe. There was an issue raised about the electric universe. Now I'm going to be talking a little bit about this fellow, Wal Thornhill. Okay. Uh, as part of that, I'm going to look at Nassim Haramein, subject that I forgot to mention the other day. Someone raised the issue, and so I'll cover that briefly. And that's going to lead us into the topic of today, which is what is gravity? Okay. And then I'm going to look at the science critic. He made a video, 45-minute video about the scientific method, and he criticized it. So now we're answering point by point. And the main point there is that he says that no one can understand quantum mechanics. And yes, we agree with that. And then we're going to look at the flat earthers. And now it's 6 weeks. 6 weeks that they do not understand the question. Obviously, if they do not understand the question, they can't answer the question. And this also means that, this explains to some degree why, after 3,000 years, no one has been able to, in mathematical physics, mathematics, been able to answer what gravity is. Okay? And neither can the flat earthers, obviously. Anyways, and then we're going to go with the questions and comments that people made since last time. Okay, so moving on here, let's look at the electric universe. Fellow raised this issue. He said, okay, good, thank you. Says, there is no one in the electric universe community that claims gravity is equivalent to electricity. Why don't you provide a citation? And to me, this is incredible that someone would say that. It seems to me that some of these electric universes and other sects out there, they do not understand their own religion. They go to, I guess, electric universe uh, church on Sundays, Sunday schools, and they don't understand what they're listening to. And here on the right, I provide two examples. These are just two examples. One is from Immanuel Velikovsky, Russian fellow, and he's one of the founders, you could say, of the electric universe idea, okay, a long time ago. And he said in one of his papers, says, cosmos without gravitation, attraction, repulsion, and electromagnetic circumduction in the solar system. Okay, and one of his disciples is Wal Thornhill, and he's the head, I guess, the main person in the electric universe today. And he wrote a paper in 2008, Electric Gravity in an Electric Universe. So it looks like these people are saying that gravitation is really electricity. Okay, so I just want to establish that first, that this is what the electric universe believes in, what they propose. This is their theory that there is no gravity out there. Um it's really all electricity. Okay, that is their argument. Okay, what's the issue? And for this, you got to look a little bit about the history of the electric universe. And I want to first establish that Wal Thornhill, who is the head of the electric universe today, right? He was in contact with Velikovsky first, and also with another fellow. His name was Ralph Sansbury, and these people proposed, and Wal Thornhill still proposes that that gravity is really electricity. More so than that, more important than that, to answer this fellow's question, they say there is no such thing as gravity. Okay, because gravity itself is electricity. That's the argument. Okay, so here we go. First, Walt Thornhill had a video done in 2017, one of the conferences the Electric Universe had, and in it he brings he presents Velikovsky, and he talks about the fact that Velikovsky wrote a book that I guess he gave also to Walt Thornhill, titled "Worlds in Collision." And it says there, Velikovsky's Astrophysics. That's the title of the video. You can look it up in YouTube. And he says there, gravitation is an electromagnetic phenomenon. Okay, so I think that's quite clear there. They're saying that there is no real gravitation. It's electricity or electromagnetism. Okay, just want to establish point by point here. First, we're going to say that what these people are saying, you cannot yet say at this point, right? You cannot say that there is no gravity according to the electric universe. But what we are saying for sure so far is that the electric universe says that gravity, the one at least in our local area, our solar system, is electricity. That's what they're saying. Okay, and we're going to go beyond that. Okay, but let's first establish that point. Okay, here is why Walt Thornhill followed Mr. Velikovsky, and he says the following. He says, one of the tests of a good hypothesis, because it's not a theory until it's being tested experimentally or observationally, is the more outrageous yet correct a prediction is, the more weight it should carry in favor of that hypothesis. And Velikovsky predicted that, and he goes on giving an example about Venus, okay, which is not relevant. The issue here is that no, a hypothesis, first of all, is not a theory, which is what he thinks it is. That's where he starts failing. That's where the electric universe starts failing. And the other one is that in science, we do not do predictions and we do not test anything. We do not do experiments. Let me repeat that. Someone says you may have misspoken. No, no, in science, we do not do experiments. I hope that's very clear, okay? And we do not observe, we do not gawk, okay? What we do in science is explain. We explain experiments and we explain our observations. If you have not explained, you're not doing science. Okay, so if you just described that what you did in an experiment or what you observed, you haven't done science, and that's where Walt Thornhill already fails. He's got the foundations of his electric universe already on the wrong footing. Okay, and so, yeah, and we don't do predictions again. We don't do experiments. We do, and a hypothesis is not an untested theory, one that requires evidence of any kind. That's not what a hypothesis is. So, Mr. Thornhill already starts on the wrong footing because he's got the uh, scientific method wrong. It's his notion of the scientific method is irrational. A lot of that has to do with the fact that no one in the last 3,000 years defined unambiguously what the scientific method is. Okay, and when they put things such as equations, they put things like experiments and predictions and observations and all these other things that they put in there over the years. Well, for sure, it's irrational because I can run an experiment. Here's an experiment. I let go of the spoon, falls to the floor. Okay, and so I ran the experiment. Does that make me a scientist because I ran an experiment? I can even do it repeatable. I'll do it again. Okay, just in case. Okay, repeatable experiment. There it is. Am I a scientist because I observed the spoon fall? Obviously, it's just observation and we're running an experiment. We have not done science. Science requires that you explain, for example, why the spoon dropped, what caused it to drop. And that's the type of questions people, for example, in Quora ask all the time. What causes gravity? That's what people want to know. That's what they want to understand. And that's where we have a problem today. Okay, we don't have answers to those types of questions. Therefore, the scientific method that they've been using for the last 400 years does not address those questions. Okay, so here is what science is not, okay, versus what science is. Science is not skepticism, okay. People say, "Oh, you scientific skepticism." No, no, no such monster. Okay, there is no skepticism in science. Science, you can criticize, but that doesn't make you a scientist. This is like saying that you're a boxer because you're a reporter who's sitting in the audience and you're watching, the fight, and you criticize the fight. And you say, "Well, he shouldn't have hit him with a right. He should have hit him with a left, or he should have been faster, or should have ducked." That's not a boxer. That's a reporter. Okay, so the fact that you're a critic does not make you a scientist. The scientist is the guy who's in the ring fighting. Okay, the boxer. That's the boxer, and that's what a scientist is. You have to go in there with a theory, an explanation, and defend it against someone who attacks it. Okay, that's a scientist. So none of these things, observing, measuring, equations, predicting, doing experiments, testing, repeating the experiment, repeatable, presenting evidence, verifying, persuading. None of that has to do with anything with science. Forming clubs, some organization, making money off of it, giving out prizes. None of that has anything to do with science. Okay, that's all. Some of it is politics, some is religion, which is a synonym of politics. Okay, science, explanations, and it's got to be a rational explanation, otherwise it's not an explanation. It's an explanation perhaps in ordinary speech. That does not make it an explanation for the purposes of science. Okay, so here's Mr. Walt Thornhill, and he met Mr. Ralph Sansbury some couple decades ago, at least. Okay, this is what Mr. Sansbury says. Okay, he was also one of, you can say, the proponents of the electric universe. So if you want to know whether electricity is gravity and gravity is electricity, well, he's the right man to see. In fact, that's where Walt Thornhill got a lot of his information. One of the things that Sansbury said is he explained magnetism and gravity as the response of the orbitally structured electron and proton to the electric force. Mr. Sansbury thought that gravity was really electricity. Okay, and that's what he explained. Here's another piece of evidence for that. Okay, here it is. This comes out of Thornhill's paper, just I think an informal paper, but it's online from 2008, Electric Gravity in an Electric Universe. And this is what Mr. Thornhill says. He says, the force of gravity is a manifestation of the electric force. Gravity is due to radially oriented electrostatic dipoles inside the Earth's protons, neutrons, and electrons. He got that from Sansbury, and there's the reference, okay? And then he ends his paper saying, gravity is an electric dipole force between subatomic particles. On the right, you see a little drawing. You can look that up, what it's all about. But I'm just going to point out what's there underlined. The like magnets that are free to rotate all the electric dipoles in protons, neutrons, and electrons line up to produce gravity. Okay, so this is what Sansbury came up with, and this is what Mr. Thornhill inherited. He subscribed to that notion, and that's what the electric universe has today. Okay, but let's get to the bottom of it. Okay, this fellow said, yeah, but no one says in the electric universe that gravity is actually electricity. Like, there is no such thing as gravity, right? That's I think what he was referring to when he asked that question. Okay, and so here it is. This comes from the book. This is one of the main books of the electric universe, A Beginner's View of Our Electric Universe by Mr. Tom Findlay. And he says the following. He starts out by saying what the argument presented by the electric universe, that the electromagnetic force is way stronger than gravity. Okay, so they said, look, it's much, so many magnitudes greater than gravity, So we have to look at electromagnetic force because you would not be able to explain gravity here in the solar system with this puny force known as gravity. But then they contradict themselves because, if you listen to that, you would say, okay, it looks like there's a difference between the electromagnetic force and gravity, according to the electric universe. And now all these other statements say exactly the opposite. There is no difference between gravity and electricity. In fact, gravity itself is really electricity according to the electric universe. So it says this fellow Finlay says the following: says those who had dedicated their lives to scientific research based on gravity have wasted their time. Gravity is a manifestation of the electromagnetic force. Gravity itself is fundamentally electrical and just another aspect of the electromagnetic force. The four fundamental forces, the weak and strong nuclear forces, electromagnetism, and gravity, will all eventually be seen as having their common root in the electromagnetic force. According to the electric universe, there is no such thing as gravity because everything, absolutely everything in the universe, is electricity. And then you have the problem of, hold it, I thought you said first that electricity was so much more powerful than gravity, and now you're telling me that gravity itself is actually ultimately electricity also. Okay? So, yes, that is the theory that the electric universe proposes. They have no respect whatsoever for gravity. They have no idea what gravity is. They don't care for it. They never talk about it except to criticize it. 150% of the electric universe is electricity, and they, under all circumstances, deny that there is such a thing as gravity out there. Okay, so I hope that's settled. I mean, it's up to other people to come up with, you know, why they think differently to that. Okay, so why is the electric universe irrational? Well, here's a rundown, a quick one that I just wrote the other day. I'm going to go through it real quickly. Gravity is electricity. That's already irrational. Electricity has absolutely nothing to do with gravity other than the fact that they're both mediated by the electromagnetic rope. Then, yes, you could say that gravity is related to electricity and to magnetism or electromagnetism, if you will. Uh, the issue there is that they're two different phenomena, anyways, even under the rope model. Okay. What's the problem? The big problem is they can't even define the word electricity. And I talked about that the other day. I'm not going to go through that again, but you can look up the previous two videos where I discussed that. And what is electricity according to the electric universe? Well, it's some kind of river. That's the way they envision it. And so the question is, if it's a river, are we talking about the water or the flow? So, water is made out of molecules, and all these molecules are flowing downwards and they're moving, right? And we call that a river, moving water, okay? So when we say river, are we referring to the water or as the thing? Or are we referring to the flow, what the water is doing? I hope you can understand the difference there, okay? And we say rivers both, right? Well, electricity is both. Electricity is both the electron beads and the flow of these things, these beads. So when we say that we have electricity, right? Are we talking about the bead, the electron bead, which is the object in this case, or are we talking about the flow? Okay, which are we referring to? Electricity is both electron flow, according to the official version and according to the electric universe. Okay, so you can't say that electricity itself moves or does anything. You can say the electron bead does something, but you can't say the electricity moves or does this or does that, because electricity is already flow, it's already in motion. Electricity is a dynamic concept, meaning electron flow. That's what electricity means. The word electricity means that electron flow. So you can't say the electron flow flows. okay, which is what the electric universe does constantly. They say electricity flows or moves or goes from one region to another, from one pole to another. You can't say that in science. You can say the electron bead moves, but you can't say the electricity flows. Okay, and that's where we have a problem. It's more than semantics. It has to do with the fact that these people treat electricity as a physical object. And when you say it's not a physical object, they say, well, why don't you stick your fingers in an outlet and you'll find out if it's an object. Because I guess that's the way the electric universes determine objects. They say, look, you want to see if an elephant is an object, go touch him. And if he kicks you with his trunk, then you know it's an object. That's the way they determine it. And in the case of electricity, they say, what we do, we stick our fingers in an outlet, and if it gives us a shock, we know that electricity is an object. That's the way they determine it there. Again, totally irrational. Okay, they invoke discrete planetary atom that quantum bequeathed to them. They use that planetary atom to explain ionization, electricity, the whole works. So it turns out that they built these filaments, which they say interconnects the universe. But it turns out that the filaments themselves are built by electricity, which is what? The flow of electron beads in one direction, actually. And so the question is, how can you unite? How can you bind? How can you connect the universe with discrete particles that are flowing in one direction? So these filaments are misconceived. They have not, defined them very well. They like to talk about the filaments and they show you pictures, but then when you go to the nitty gritty and say, well, what is a filament? Well, they say it's a flow of electricity, which already is wrong. You can say it's a flow of electrons. They go in one direction only. And one question there that pops up, which sun is the positive and which star is the negative pole? And what electricity travels at the speed of light, maybe, and that's what connects the universe. So yeah, a discrete universe that the electric universe inherited from quantum mechanics is just as irrational as anything coming out of quantum mechanics. Okay, all the physical interpretations are bunk. That's essentially it. Okay, then they treat plasma as an object, as a thing, and that takes 2 years to explain to electric universer that plasma is not a thing. Like electricity, plasma is a flowing river. In other words, a river that has something that is flowing, right? It's a thing that flows. That's what a plasma is. Okay, there is no standalone object called plasma. And let me prove it to you. Okay, I'm going to prove it to you. Here's they say plasma is the fourth state of matter. That's what the electric universers like one of the definitions they have. One is the fourth state of matter. And so we have solids, liquids, and gases, and then they say there's a fourth state of matter, and that's known as plasma. Okay, so what's the issue? The first issue is that, state, the word state, refers to what something does. It does not have to do with what something is. Okay, so if I show you a table, I say that's an object. It's standing still right there, and it's not really moving at that specific moment in which I point to it. Okay, the table, in fact, even if I don't point to it, the table is there and it has shape all on its own. It's standing there. Okay, and so the issue is that there is no motion essentially of the table. I can take a snapshot of the table and say that's a table. Okay, point to it, and the ET, the Klingon that's next to me, he understands the word table because I point and he recognizes what the word identifies. He says, okay, that object there, that's called table. That's how it works. Okay, so here we point, okay, and we have a box, okay, and we call that a solid. Is the word solid a physical object? No, solid is a category. Okay, solid is a category. You have many solids boxed under that heading known as solid. Okay, I point and I say liquid, and I can take a picture of a liquid. Okay, which I threw right out of my spaceship. And that blob there, that has shape. You can see that it has shape. Okay. And we call that a liquid, some kind of liquid, blue liquid. It could be water. Okay. Would freeze immediately. But what you see is something that has shape. Okay. And obviously, I can also throw gas outside my window. Okay. And I don't know why this isn't coming out. I don't understand why some of my pictures are not coming out lately. Anyways, there's gas. You can have gas as well. Okay. But, and we all know pretty much it's just a bunch of atoms, okay, at a certain distance. You can throw them out of your spaceship as well. I hope this one comes out. And here's, okay, there's your gas, okay. But you can't do the same thing with plasma because plasma is always moving. Plasma is ionized gas. Ionized is something in motion. Ionized means, according to the official version, that an electron leaves the atom. Could be acquiring one. Let's go with the one that it leaves the atom, okay? So the electron leaves the atom, and suddenly that atom is ionized. That's what ionized means. But plasma is a process. Plasma is a process where you strip an electron from an atom. Okay, that's what plasma is. That's how it's defined. And these people say, no, plasma is a physical object because I'm staring at a physical object. No, I'm not. I'm staring at a movie of something in motion. I don't have to do the same thing with solid, liquids, or gas. I can take a snapshot of solid, a liquid, or a gas, and I will have something in the photograph. Okay, I can't do the same thing with plasma because as soon as I take a picture of it, it's no longer plasma because plasma has to be moving, has to be ionizing. It's a process that is in motion. Whatever I take a picture of is not plasma. I've taken a picture of maybe a bunch of atoms, maybe a gas, but certainly not plasma. Plasma has to have the word ionized in it. It's part of the word plasma. Okay, so if I take a picture of plasma, I'm taking a picture of ionized gas, but not ionized because ionized means motion. Therefore, it's not, I haven't taken a picture of ionized gas. Ionized gas is a movie. Okay, it's a film. Plasma is a film, therefore, it's not a standalone object. And yeah, it's one of the issues that we have is that the electric universes don't understand that argument, and they say, "Well, Bill, what you're doing is a lot of semantics." They dismiss all that as semantic arguments, and yeah, what can I say? Science is 100%, 150% semantics. Here's one fellow who criticized me, and he says, I think you're taking your semantics a bit too far. You need to bring it down a few notches, otherwise, you'll never be taken seriously. It's too much. And yeah, what can I say? That is exactly what science is. Science is 150% semantics. Okay, and people say, well, I don't want to do semantics. I came here to do physics. I didn't come here to do grammar or learn English or whatever. Uh, Science you need to define so that you can communicate your ideas. And you say, well, I don't know what plasma is, but let's continue. I'm going to treat it as an object and I've never defined it, but I'm going to continue. You can't do that in science. We need to know what plasma is. We need to know what ether is. We need to know what all these words mean exactly before we move on, before you can begin your presentation. And so these people don't like definitions because it destroys their religion. That's the primary reason. Okay. Okay, a couple more problems with the electric universe. They introduce metaphysics jargon. In other words, it's the mathematicians who have fed the language to the masses, to the laymen, and to people like the electric universe and others, flat earthers, especially, And they use the words that they were taught in high school and college. And what are those words? Those words are, words of mathematics. They're not words of physics. They're words of mathematics such as energy, mass, force, field, time. Those are all words of mathematics. They have nothing at all to do with physics. Nothing at all. We don't use those words in four-letter words in physics. Okay? So please don't bring any of those words to explain anything in physics because they have nothing at all to do with physics. Okay? So that's the issue. And the other problem with the electric universe, they propose experiments, and because they've been taught the irrational scientific method that they inherited from the mathematicians of the 17th century, and they're just following that irrational scientific method. So they think experiments, predictions, and all this stuff has something to do with science. It don't. Period. Okay, it has nothing to do with science. And they, just like all the others, they criticize the establishment because it censors them, but they do censorship as well. So that's everybody does censorship, as far as I know out there. Okay, one good thing about the electric universe, not all bad, is here. This comes also from Mr. Thornhill, Walt Thornhill, and what he says that the universe, according to him, is connected. Sounds a lot like Mr. Haramain, which I'm going to talk briefly next. But he says the universe is connected. And what does he connect it with? Well, he connects it with electrical force, electric force. He connects it, he says, since all matter in the local universe is connected in real time. So he says it's connected. What he connects it with? He connects it with all these concepts. Okay? He talks about instantaneous motion. He says electrons exchange energy instantly. Instantly is an irrational term. There's no such thing as instantly in physics. Instantly is a word that belongs also to mathematics, to the religion of mathematical physics. It's an instant is just one frame of the film. That's what instant is. There is no motion in instant. Okay? It happened now in the cross section of time, in one frame of the universal movie. That's an instant. Okay? There is no interval called instant. Okay? And so these people want to say instantly, like motion happened in one frame of the film. That's what they're saying when they say instant or it happened instantly. No such monster in physics. In physics, you either have one frame of the film or you have many. If you have many, it's called a film, and it's not instant. Okay? And if you have a single one, then you can call that an instant. Okay? Cross section of time, now, all these synonyms. That's what an instant is. Okay? So when these people talk about electrons exchange energy instantly, they're saying there's motion, but it happens so fast that it all happens in a single frame of the movie. That's what they're saying. And again, they don't even understand what they're saying. That's the issue. And then, so he says all atoms are connected. Somehow the universe is connected, but he connects them with what? Electric force, energy, concepts. That's what he connects them with. And yeah, that does remind me of Mr. Haramain, Nassim Haramain. I talked about him last time. And a fellow says about Nassim, which he brings up, he says, I have opened the third eye. Oh, he opened his third eye. Okay, I don't know what planet he came from, but he says he's got a third eye. Okay. After that awe-inspiring experience, I sampled shrooms and am open to ayahuasca. I would love to party with Nassim. Yeah, I guess if he's got a third eye and drugs himself, I guess that must, make him horny. so, so Nassim better watch out. He doesn't know all the admirers he's got out there. Anyways, this fellow says, Nassim Haramein. And this is what I forgot last time. He makes his money, apparently. He says his art crystal is providing substantial income due to an overwhelming market. And yeah, that I can believe that. Nassim is more into that than into science, than to physics. Okay, now some people say, Bill, you're taking too many liberties. In fact, I think it's the next fellow up here. He says the following. He says, you overstep when you pretend to know people's motivations for doing the work they do. There's nothing incompatible with making money and doing work you believe in. Yeah, okay, nothing wrong with that. The only thing is, my take on this is a little different. In the case of Nassim, I think that Mr. Nassim is not so interested in science, especially after his only paper that he published in 2013 went nowhere, especially with the establishment. And because it went nowhere, Mr. Nassim Haramein, he branched off, okay, into other things. He created this Resonance Science Foundation. And this is my take on him. Again, my personal opinion. I think he's an ascetic only in the sense that he introduces spiritualism and transcendentalism into physics. He certainly is not dispensed with a frugal lifestyle, characterized by what? Renunciation of material possessions and physical pleasures. I think Mr. Nassim Haramein is more a businessman than he's a scientist. I don't think he cares about science at all, especially today. Okay, he knows he can't get his stuff through the establishment. You know, he's trying to say that the world is connected, and again, he doesn't tell us what it's connected with. Maybe if he could tell the establishment what it's connected with, the establishment would maybe take interest in what he's got to say. But since he's just repeating what the Buddhists and the Hindus have said for thousands of years, saying that the universe is connected. It's all intertwined somehow. But they never explained with what. What physical entity interconnects the universe? Mr. Haramein hasn't said so either, and neither has Mr. Wall Thornhill for the electric universe. They all talk about interconnection, filaments, everything being connected, bounded, bounded, and none of them tell you with what. What is it that interconnects us? And that's what this site is about. We are the first site that says what, a physical entity, a what interconnects the universe. That's where we differ from all these other folks. Okay, so let's move on to gravity. See what gravity is. What gravity is. What is gravity? I mean, we talk about gravity and we see the spoon fall to the floor, and we say, yeah, that's gravity, and that's as far as we go. We don't know what it is, what caused it to do that. I mean, if you see someone pulling on a donkey, you say, well, I know what caused the donkey to move forward. It was the fact that this guy was pulling on a rope. Okay, so we know what caused the donkey to move forward. Okay, and it's straightforward, and it's just self-evident. But when you say, look, what caused this to fall to the floor, we say, well, I don't know, but it happens all the time, and we call it gravity, and that's it. We have a name for it, but we don't have an explanation for it. We don't have a physical interpretation. After 3,000 years, okay. And what is the issue? The issue is that the only issue, the reason no one has an explanation, is they cannot see or touch the mediators that cause this to happen. That's the only reason. See, if we could see, we had God's eyes and we could see what's there, whether something pushing or something pulling, we would say, okay, that's straightforward. Something's pulling on it or something pushing on it. And it's this, because I can now see it, I can make it visible for you. But as long as it remains invisible and untouchable, it's stumped all the researchers throughout history. And that's the only reason we cannot explain it, because we cannot see or touch the mediators. But what's the issue? The issue is if you do not mentally put in there some visual, some entity, some things, some objects, then you're explaining this with black magic. You're explaining gravity with black magic. Okay, so you're saying it just happens by black magic, by remote control. The earth pulls on it somehow, or maybe the moon pushes it on it somehow. All you're saying is that there's remote control. God is doing it, the angels are doing it. And what mathematical physics has done all these years is put concepts in there, and they say it's force. it's field, it's mass. And then the flat earthers say, no, it's density. And they have all these words and they don't realize none of them are physical objects. We need to know what physical object is pulling or pushing on the spoon. If you do not put a physical object pushing or pulling, you are essentially explaining this phenomenon with black magic. So you cannot use words such as density, mass, gravity, force, field, concepts. You cannot put concepts to explain that phenomenon. That's the bottom line. And so that's what we have today. We have just concepts. So people are explaining it with black magic. And so one fellow asks about my site. He says, how about you, Bill? Okay, so apparently he wasn't familiar with what we do here. Okay, so he asked the following. He says, you explain that every atom is interconnected to every other atom in the world. Correct. That's what we're saying. In the universe. Not only our world, like our planet, the entire universe. Every atom in the universe is connected to all others. Okay, I want to make sure that's clear. Okay. What is the physical nature of the interconnection of all atoms which pulls on all other atoms? Okay, that's the question, and he wants answered specifically. What is causing that force which binds all objects together in a pull? Okay, repeat more or less what he wants to know. Okay, science without experimentation is only philosophy. Well, there he's totally wrong. Again, he's got the wrong scientific method, the irrational scientific method. He's saying that if I run an experiment, okay, and I'm going to run an experiment, and there it is, there's the experiment. I threw or I let go of the spoon, okay, I'm not throwing it, I'm just letting go of it, okay, and it always falls to the floor by magic. And he's saying without experimentation. Well, I did an experiment. So what is this, just philosophy? People want to know or understand, right? What causes this to fall? And he's saying that's philosophy. If you don't do an experiment, well, I'm doing an experiment, and so does that make it physics because I did an experiment? So again, he's got the irrational notion of what science is, okay, what physics is. Another fellow similarly asks about this site. He says, Bill, which theory do you follow on the mechanics of cosmology? And I guess he's referring to electric universe, flat Earth, quantum mechanics, not quantum, but general relativity, string theory. He's talking about cosmology, talking about the big picture, how the universe works, gravity at the universal level, right? And so he wants to know how that works, according to, which one I subscribe to. And the first thing I want to make sure I don't subscribe to any of those, okay? I don't subscribe to flat Earth. I do not subscribe to electric universe, general relativity, string theory, or even quantum mechanics, which is not a cosmological theory, but I don't subscribe to it either. None of those have anything to do with rationality, with physics, with science, with anything. All those are irrational. Therefore, they have nothing to do with science. So I don't subscribe to any of those, okay? But I do have something to propose in the alternative, and that's what this site is about, okay? And yes, it has to do with interconnectivity, because we're going to show that gravity is not an action at a distance phenomenon. Gravity is just like any other phenomenon. The only difference between regular everyday phenomena is that we can't see the mediators. We can't see or touch the mediators. That's the only issue. If we could see and touch them, it would be kindergarten stuff. You would say, okay, I see what's causing this. Something is pulling on it, which is on our theory. We're saying there's a pull there, okay? But, as long as you don't see anything there and you're expecting to see or touch something, you say, let's go to the lab. Let's run an experiment. Let's use our eyes and our hands to detect what's causing this. And you're an irrational individual because Mother Nature, Father Universe, God, the devil, whoever you believe in, they don't do gravity with visible and tangible things. Their mediators are invisible and intangible. They're things, they're objects, they're entities, but they're not visible or touchable. And until you grasp that, you're going to chase your tail around forever. That's the story from this site, okay? So let's go with what someone proposes here, and that's quantum mechanics in general, or you could say it's really mathematical physics in general. I put quantum mechanics, but because that's the one that deals at the microscopic level. But really, this is all of mathematical physics, and in fact, this is what they have proposed for 3,000 years. What you see there on the left-hand side is discrete particles, just forming part of the vacuum. Some people equate it with a vacuum. Some say that the particles are floating in the vacuum, okay, in space. Okay, there's these two versions out there. But what you're staring at is the ether. Okay, the ether is a bunch of discrete particles that form the backdrop to everything out there in the universe. That's what the ether is. That's how the Greeks conceptualized it, and nothing has changed in 3,000 years. Anyone who says that ether is anything other than what you see there, a bunch of particles, does not know what the ether is. And so the onus is on that person to one of the two: either draw, illustrate, take a photograph, make a mock-up of a statue or whatever of the ether, or define the word ether unambiguously. If he cannot define the word ether unambiguously, he cannot even start his presentation. We need to know exactly what the ether is and whether the ether is equivalent to space, vacuum, nothing, or whatever you want to call it, or whether the ether, meaning these particles or whatever the ether is inside. It's contained, so to speak, within space. In other words, if ether and space are two different things or the same thing, that's what we want to understand before he can start his presentation. We need to know if it's a physical object or if it's an abstract concept. A concept is something you define. An object is that which you can point to because it has shape. And if it has shape, there should be no reason for anyone to have an excuse to say that they can't draw it, they can't illustrate it. On the other hand, what do we propose? The rope hypothesis, there you have it: interconnected atoms. All atoms in the universe are connected, bound to each other by something that is there that we cannot see or touch. In fact, we cannot see atoms. So for people to request to see the mediators that bind two atoms, it's irrational because we cannot even see atoms. No one has ever seen a hydrogen atom, let alone what interconnects two hydrogen atoms. Okay, so until you get a grasp of that alone, you got a long ways ahead of you, because you don't understand half of it yet. Okay, so what happens here? We have two atoms, okay? And you can see what quantum mechanics, essentially mathematical physics, proposes, okay? And that's the quantum atom. You have a little ball in the center called the proton. They call it a positive particle. We don't know what positive is, okay? Positive is just the opposite of negative. They could have said it's the A or the Z. They could have said it's west or east. They could have said north and south. They could have said any two opposites. Could have called one the yes and the other one the no. That's what positive and negative really mean. We don't have an idea from the mathematical establishment what positive and negative mean in physical terms. So they put a plus sign and a negative sign, these ridiculous symbols, to say they're opposite, whatever opposite means in physical terms. And so that's the atom, and that little red ball, that's called the electron. It's supposed to go around or somewhere around the proton, and that's why those dotted lines, essentially, it's an orbit, and they call that orbit an orbital. That they have converted the region in which you can find an electron bead, they call that an orbital. So the region, which is a concept, has been turned into a physical object, some kind of shell of sorts, okay, like an eggshell. And then one atom can influence another one through what they call entanglement, or through gravity, or through whatever action at a distance that they want to talk about. And what is action at a distance? There is no mediator between two atoms. These are all discrete particles. They are discrete atoms. And even within the atom, we have discrete particles that we have no idea what binds them together. We have no idea why the electron doesn't spontaneously leave the atom, or why it doesn't fall towards the nucleus. Why does it uh, remain in a region known as the orbital? Okay, that or energy level. That's what we want to understand, and we don't have an answer to that. And mechanics, the quantum mechanics people, they just say we don't understand it either, but let's continue. Okay, that's the way it works. And a lot of people think that they do understand it because otherwise we wouldn't have all the technology that we find out there. Okay, on the bottom you see the rope hypothesis. We have a physical mediator, okay? And that means that one atom is bound to the other physically, so they can't leave, like one atom can't leave the universe or the space. First, because space is nothing, a synonym of nothing. That means it has no shape. Nothing can leave that which has no shape. You have no border to cross. That's one reason. But even assuming space had a border, surface, the atom couldn't leave it because it's bound to all other atoms in the universe. Okay? And so that's you can see the difference there. Our atoms are bound, their atoms are not, and our atoms have this three-dimensional atom that you see there. It's essentially made of the same thread that forms the rope. Okay, that's why it's called the rope hypothesis. And one of those threads goes around and forms the electron shell, and all the threads from every atom in the universe weave around and comprise the electron shell, while the other thread that forms the rope goes right through the center of the atom and forms what we call the proton dandelion or star. Okay, so we have all these uh, threads that form the atom itself. Okay, so not only do they form the rope, but the atom that's built from the same threads. Okay, so that's the proposal. Okay, and here we see them in motion. Okay, you have the quantum mechanics version up there. We have a little ball that somehow falls between these two energy levels. It doesn't fall all the way to the center of the atom, which is that blue ball, which they call the proton. Okay, and at the same time, it doesn't leave the atom itself unless it's ionized, forming what is going to be called plasma. A bunch of atoms which are ionized, that's plasma. Okay, and again, they have this action at a distance. It's black magic. That's what action at a distance stands for. Whenever you hear that, you hear black magic because they're saying there's no mediator, but one atom influences another, even if it's at the other side of the universe. That's what these people are telling you. Okay, okay, and at the bottom you see our model, and that is that the atom is a membrane, which we call the electron shell, which encapsulates the proton star. Okay, and all of this is made of the same thread as the rope which binds any two atoms. An atom can approach another one, and it does so by swallowing thread from the rope. Okay, so as it pumps back and forth, which is what we call the quantum jump, it approaches another atom by sliding, or like a bead on an abacus, essentially. It doesn't take the wire with it. And this is more or less the same thing. An atom just approaches another atom, eating rope as it approaches the other one, until, for example, it can form the H2 molecule, which means that there is no more rope between them. What we have at that point is just the merged shells. Okay, so this is the proposal. This is what we propose in exchange for quantum mechanics and mathematical physics in general. Okay, okay, so one fellow brings up, and he summarizes essentially the version, cosmological version that mathematical physics has for gravity, which is what we're talking about right here, okay? And this is it. He says, general relativity, Einstein's theory of gravity, is the geometric theory of gravitation. Geometric because they say it's the modification, the distortion of space-time, which is supposedly this four-dimensional medium, okay? An ocean, think of it like that, okay? But it's a four-dimensional ocean. That's how they're going to illustrate it, okay? Usually in two dimensions. Well, two really, it's a 3D projected onto 2D platform. That's what you see there, okay? The current description of gravitation in modern physics, yeah, modern mathematics, okay, modern mathematical physics, which is not physics at all. General relativity describes, and see, he's talking about description and describing, okay? Yeah, mathematics can only describe, and that's what general relativity is. It's a description. The explanation, the physical interpretation is totally irrational. Bunk. It's nonsense. But what the mathematicians are concerned about is the mathematical description. That's what general relativity is, just a description. That's why they love it so much, okay? Describes how properties of the world change in the presence of sources of gravity. General relativity explains the laws. No, first, we have no laws in physics, and certainly general relativity doesn't explain anything. The explanation is, again, warp time, warp space, and that's not a rational explanation, meaning it's no explanation at all. In maybe in ordinary speech, in religion, that could be called an explanation, not in physics, not in science. An explanation has to be rational in order to be an explanation. Okay, so explains the law of gravitation in its relation to other forces in general in nature. Okay, so what is uh, a rational explanation? Because this is an irrational explanation, therefore it's no explanation at all. This is not an explanation to say that time warp. Okay, time is warped, and that's what prevents the Earth from flying out of the solar system because time is warped. No way, you can't do that. Not in physics. Okay, and so here we have the criteria for irrationality. Okay, irrationality. The main one is number one: treating concepts as objects. Okay, reifying objects, concretization. Okay, and what they're doing is they're turning words such as field and energy, mass, into physical objects. And they start moving these things around. They're saying, oh, we transferred energy. The field is vibrating. It's an excited field, and the mass moved and so on. No, you can't do that. Not in science. So those are irrational physical interpretation. When you put a concept and you start moving it, vibrating it, whatever you do with it. Using inconsistent or undefined words, inconsistent definitions or undefined words. The theory doesn't follow from the hypothesis, from the assumptions. Okay, the explanation doesn't follow from what you presented up front. Describing and claiming to have explained, and the mechanism cannot be even imagined. Okay, so whatever when general relativity says that um, gravity is the something to do with space time, meaning that it's the warpage of space time or the bending of time or anything like that. Those are irrational explanations. And if it's an irrational explanation, you cannot even imagine it. I mean, what are you going to imagine for warped time, for bent time? What is that? The seconds are bent? Is that what these people are saying? Okay. And so, maybe here you can see a little bit of that, okay? Here's Einstein. He says he warps the seconds, the time warp. Okay? Is that what we're supposed to visualize? Is that what we're supposed to imagine, that time is warped, meaning the seconds? Maybe it's the minutes, the years. I don't know. Whatever unit they want to put in there, or maybe they're warping something else. Maybe they're talking about a different kind of time, like this one. Money. They say time is money. Is that what they're talking about? Is that what they're warping? All these people who are the disciples of Einstein today. Okay, so yeah, this is the problem. The problem is that you cannot say that you're gonna do time warps and that's an explanation for how the universe works or why the Earth doesn't fly out of the solar system. Okay, and this is essentially what they're saying. Okay, in general relativity. Okay, that there's a wall of time. It's a curved wall of time, and that's that depression that you see underneath the sun there. So the sun somehow weighs this down with its mass, because it's not the sun, it's the mass of the sun that's weighing down the canvas. And what is the canvas? It's length, width, and height plus time. Okay, so essentially we don't care about length, width, and height in this case. We're saying that what the mathematicians are saying is that mass is pushing down the canvas that includes time, and therefore time is a wall that prevents the Earth, or one of the components of this space-time thingy, that prevents the Earth from flying out of the solar system. That's what they're saying. Okay? And yeah, it's like the roulette mechanism. So you don't have to be a genius to understand what these people are saying. They're saying that mass warps space time, meaning time. Let's forget about space for a moment. It warps time, and that warp time is what prevents the Earth from flying out of the solar system. Obviously, it's unimaginable. And if it's unimaginable, they don't have a physical interpretation. And the question is, why did they even attempt to give a physical interpretation if mathematical physics, does not provide physical interpretation, if that's philosophy, as they call it? In the end, when you put them against the wall, they say, well, that's philosophy anyways. It's opinion, so to speak, religion. They don't care about it. And you say, why did you even attempt to give a physical interpretation to your equations if you're going to give an irrational one and at the end say, well, it's just philosophy anyway? See, this is the issue. The issue is these people claim to know how the universe works. They don't know how the universe works. They don't understand how it works. And then they say, well, that's philosophy anyway. That's where we're at today. Okay, what's the quantum version? Because that's the cosmological version. How about, this little spoon and falls to the floor, okay? And you say, well, why did that fall to the floor? How does quantum explain this at the, everyday level, at the micro level? Because relativity, again, is out there. Relativity is not used to explain this, okay? Or even describe this. There is no warped space near the spoon so warped that it creates this effect. Okay, and a lot of people don't understand that. They say, oh, general relativity explains this. No, general relativity does not work here on Earth. It works out there at the macroscopic level. So general relativity is a cosmological theory, not even a theory, it's a description, okay? Mathematical description, but it does not explain or purport to explain this. And he who doesn't understand that is not even a relativist, doesn't even understand relativity. But yeah, this is the world of quantum mechanics here, the world of everyday life. We're talking about the microscopic level for quantum mechanics, and you have to explain gravity there. But this world here, the regular world, has to be explained also in terms of quantum mechanics, not in terms of general relativity. So how do they explain it at the microscopic level, the subatomic level? Well, here it is. Okay, this is, you won't believe it, but this is the way they explain attraction in general. Okay, here's two quarks being pulled together by a gluon. But a gluon is a particle. Okay, that's what they claim it is. And so here's a quark throwing a gluon on another quark, but it attracts it. There's this attraction between quarks. Okay, they don't fly out of the solar system, meaning the little atom, that little solar system. They don't fly out of there. Why? Because the gluon keeps them together. Okay, so how does a quark do it? Well, it throws a gluon at another quark, and somehow, because the gluon goes outwards, it pulls the other quark towards it. That's what it keeps, the quarks together. And you say, how is that possible? That doesn't make any sense to say you throw something at another quark and it pulls on the quark. How do you explain that? And here you have a fellow who died a couple years ago. His name is Victor Stenger, and he was a physicist. And this is what he has to say. It says the vacuum is capable of producing interactions between particles at effectively space-like separations. And says, let me explain. No doubt the idea of motion backward in time makes a grievous attack on common sense. However, to a particle physicist raised on a diet of Feynman diagrams, motion backward in time is not at all that disturbing. All fundamental particle interactions work backward as well as forward. Okay? And so these people just do mathematics, and what they're doing is they're saying, look, to throw a particle at something and attract it is not, not beyond the mind of a mathematician. And again, these people are not doing physics. They're not doing physical interpretation. They just get away with murder saying it is so, and that's it. So all they're doing is saying, yeah, if you throw a stone at a donkey, you attract it. That's what they're saying. And you say, well, how is that possible? How do you conceptualize that? They call it negative momentum transfer. You throw the ball, but it delivers negative motion in your direction. That's okay. Mathematically, you just change the sign from a positive to a negative, right? That's it. And so instead of having positive, momentum, for example, you have negative momentum. Great. So now all you did was change the sign, which is a physical issue because now they're saying, look, that changed the direction of motion. There is no such thing as direction of motion in mathematics. Okay. So by changing the sign, all you did was suddenly you ventured into physics, okay, without anyone knowing, and say, well, I'm still doing math, and we have no problem with that because we changed the sign, and suddenly the direction of motion is in the opposite direction. That's not math. That's jumping over into physics without any, without substantiating it, and just saying that we changed the sign, and suddenly, the direction of motion changes. Okay. Again, that's a big leap of more than faith. It's ridiculous. Okay. Okay. So here we have it. Okay. This is how we explain it because all atoms in the universe are physically interconnected. Every atom of that astronaut is connected to every atom on Earth. Every atom on Earth is connected to every atom of that astronaut. And the reason he accelerates towards the Earth is as he falls, more and more independent ropes are acting on every one of the atoms in his body. Okay? So as you widen, ropes are not on the same axis. That's what's happening. They are fanning out. And so you have more what we call independent ropes tugging on that astronaut. And that's the reason for the acceleration of gravity. We have a cause, a physical interpretation for the acceleration of gravity. Okay? That's what we're showing here. You say, well, is that true? Okay. And here you see it. Here's the spoon falling towards Earth again. Okay. And what's happening, every atom of that spoon is connected to every atom on Earth. Obviously, I didn't draw every atom. I didn't draw every rope that's connecting all the atoms, binding all these atoms. But you get the idea that as it falls, the ropes are fanning out. Okay. There are more ropes that are in what we call independent ropes, that they're not on the same axis anymore. That explains the acceleration of gravity. Okay, and so one of the questions people say, well, uh, how does it work? Here it is, synthesis, okay, so that you can get the idea. Okay, you have all atoms interconnected between two objects, object one and object two. We can talk about their masses. In other words, how much they weigh if you want, how many kilograms you got in there in each one. And you have distance separating two objects. The farther away two objects are from each other, like you see there on the upper right, the more they act as one. And the closer they are together, you can see that the ropes are fanning out and you have more independent ropes because they are not on the same axis. This explains, this is a physical interpretation for the acceleration of gravity. Now the ropes don't pull. Each rope does not really pull. What you have is tension between any two atoms. The ropes are only under tension. We use the word pull because we're so used to seeing one object fall towards another, and we say, oh, one object pulled on the other. But what's actually happening is the distance shortens because, one object, as it approaches the other, the ropes fan out, and there is no pull within a rope. All you have is tension. That's why, in Newton's force law, we replace the F force, replace it with T for tension, and tension is not a force. Only in the religion of mathematics is force, tension a force. In other words, they're synonyms, not in science. In physics, tension is not a force. Force, if you look up the definition, it'll tell you that someone has to win the tug of war, and that's not the case of tension. In the case of force, something has to move in one direction or another. In the case of tension, at least between two atoms bound by a single rope, there is no one wins the tug of war. There's constant tension on it, which is, and the tension is defined by the velocity of light squared, which is, I'm sorry, by the velocity of light, which is a constant in the universe. So that is a measure of the tension on the rope. Okay, and you say, well, where did you get this? Well, we got this from Mr. Muller here. You can, not that I got it from him, but he reinforces this. He says, look, every atom on Earth is pulling on every atom of you. You are also pulling on it. The amazing thing about gravity is that it goes right through things. Okay? So I want every one of you tonight, especially if you pray every night before going to bed, I want you to say the Lord's Prayer tonight. Okay? The Lord Bill's Prayer. And here's the Lord Bill's prayer, and I want you to memorize it, okay, so that you can recite it every night before going to bed. Okay, here it is, okay? Every atom on Earth is pulling on every atom of you. You are also pulling on it. The amazing thing about gravity is that it goes right through things. Okay? So I want you to memorize the Lord Bill's Prayer and recite it every night so that you know how gravity works. And there you have the whole key. That's the whole mystery of gravity right there in front of you. Okay? Every atom of you is pulling on every atom of the earth, and every atom of the earth is pulling on you. That is the description and explanation of gravity. Okay, we have our science critic. And this fellow did a little bit of criticism of the scientific method, and he raised an issue related to quantum mechanics. This is what he's got to say about quantum mechanics. I want you to listen carefully because he's going to tell you what he thinks about quantum mechanics, the fact that no one understands it, it's irrational totally. And so he's going to kind of reinforce that right now. Okay, this is what he had to say. Give me a second here and I'll turn it on. Here it goes. Listen carefully.
The questions and issues to be addressed in this rebuttal include: if quantum mechanics is admittedly just observation and description, and beyond understanding, does it even belong in science? And is quantum mechanics just weird and tricky to understand? Or are the physical interpretations of quantum mechanics irrational and, therefore, impossible to understand?
Now, something that I don't think a lot of people realize is that quantum mechanics is not so much a theory to try and explain underlying mechanisms of the universe, it's a description of what we observe. Pretty much all of quantum mechanics is, oh, we observe this thing that happens at a small scale, this is what we found. And that is why quantum mechanics is all about observation and describing what you have observed. So that article that was cited is about how quantum mechanics is weird and we don't know why. And that's because quantum mechanics is a very tricky thing to understand. A lot of the observations that we get don't really make sense to us. But the thing is, you cannot just throw out a whole lot of observations simply because they're inconvenient to you. If you did that, well, then you'd be irrational.
Okay, so that's his point of view. He thinks that if it's irrational, if it's unobservable, you cannot even imagine it, you cannot understand it, but he calls that rational. Because if you throw it away, because we observe the visible things in the lab, if you throw that away, the description, then you're being irrational. You should not throw the observation. But the issue is that we observe the things that we can see, not the things that we can't see. And the things that they can't see, you know, the mathematicians, the particle mathematicians, what they say is the things that they cannot see, they put in the blanks for you. And they say, let us interpret that for you. What's happening in there? That's where we have the problem. We don't have a problem with the description, the mathematical description, where they say, look, this is the equation, this is how fast something went, this is what the mass was, this was the energy. We have no problem with any of that. The issue here is, what is the physical mechanism that had, you know, one particle, assuming it was a particle, right? hit another one. And, we can't see what's the mediators that bring two particles together. We can't see the mediators between two quarks. We can't see the mediators during entanglement. And clearly, there are no mediators proposed by quantum mechanics for gravity. So we can't see the mediators. And so these people like this fellow, he just believes in the establishments. Yeah, but look, the observation is correct. What observation? They couldn't observe what is invisible. Why do they even use the word observe when they cannot observe what we wish them to observe, which is the mediators? Okay, so again, if you can't observe the mediators and you put in there, by hand, sort of force push it in there, and say, well, we know what's happening in there. It's a particle that's mediating that, or it's maybe a concept like field or energy or whatever. Then yeah, then that's where we have a problem. Okay, and so first let's confirm that quantum mechanics is irrational. It's irrational. Why? Because no one, even those proponents of quantum, don't understand it. And a lot of people out there don't understand that the mathematicians don't understand their own quantum mechanics. This is what people don't understand out there. They say, well, sure, they understand it. Otherwise, we wouldn't have the technology we have. We wouldn't have computers, right? If quantum were wrong. That's their logic. And they say, well, we don't understand all that math, but they must be doing something right because they built all these computers. And so they got to know what they're doing. That's their rationale, if you can call it rationale. And so nobody's aware that the mathematicians have no clue whatsoever how quantum mechanics works. If they have no clue whatsoever of how quantum mechanics works, it's an irrational theory, whatever they propose. They have to propose a rational theory that they can understand and pass on to us. Okay, and so here it is. Here you have Dickie Feynman. Okay, he says, "Will you understand what I'm going to tell you?" And say, "You think I'm going to explain it to you so you can understand it? No, you're not going to be able to understand it. You see, my physics students don't understand it either. That is because I don't understand it. Nobody does. While I am describing to you how nature works, you won't understand why nature works that way. In other words, the causes, okay, the mechanism. But you see, nobody understands that. I can't explain why nature behaves in this peculiar way. Then he says in another of his lecture, he says, I think I can safely say that nobody understands quantum mechanics. Do not keep asking yourself if you can possibly avoid it, but how can it be like that? Nobody knows how it can be like that. The more you see how strangely nature behaves, the harder it is to make a model that explains how even the simplest phenomena actually work. So theoretical physics has given up on that. Okay, so Dickie Feynman, he had no idea whatsoever what he was doing. Okay, all they do is equations, they do math, but they have no idea how to translate those equations into physics. It's the physical interpretation, which they call philosophy when they are put against the wall. That's what they can't explain. It's the physical interpretations. That's where they die. Okay, so here we have what irrational criteria is again, one more time, so that we have it. Treating concepts as objects, reification and concretization, using inconsistent definitions or undefined words, theories inconsistent with or doesn't follow from the assumptions. Okay, describing and claiming to have explained. Mathematics does that all the time. They describe because that's all math can do, and they claim to have explained, and the explanation is bunk. It's the most idiotic thing that you can imagine, but they say, well, we gave you an explanation. And we say, but that's an irrational thing. Yeah, we don't understand it either. That's what they tell you. The mechanism can't even be imagined. Okay, so that's where what quantum mechanics is all about. And this fellow confirmed it. So he says they don't understand it. But if they don't understand it, it means what kind of explanation and what kind of theory is that? Theory is an explanation. So physical mechanism. That's what it is, what a theory is in physics. If they tell you, well, we don't understand it, what have we learned? Okay, that's the issue. Why can't they explain? Well, here's a good reason. Okay, here's the quantum atom. Okay, and again, nobody can explain the quantum atom. No one can tell you why the atom that you're seeing in front of you is like it is. In other words, it has this little bead called the electron, that blue little thing that's going around. And what happens, it falls to a lower energy level and then rises to a higher energy level. Both concepts, because those are not physical shells or balloons or anything like that, membranes. What it is, just the electron is simply going back and forth for no reason whatsoever within a region around the atom, the nucleus. Okay, so they cannot explain why it doesn't spontaneously fly out of the atom, and they cannot tell you why it doesn't fall to the center of the atom. That's where the problem is. Okay, and because they have this irrational atom, they have irrational current. You know, electricity. Because what they have is all these electron beads that are moving from one atom to another, and you say, well, before you can explain that, tell me what your atom looks like. And they can't justify their atom, let alone why the beads flow from one atom to another. So the atom that the mathematicians have that call themselves mathematical physicists is an irrational atom, and therefore anything based on that atom is also irrational, especially electricity. Okay. Okay, so here we have what's really wrong with quantum mechanics aside from that. That's one issue, but here it is. This is just a quick rundown off the top of my head. Action at a distance, entanglement, totally irrational, because anytime that they have action at a distance, that just means black magic. It means they're going to do it with concepts. They're going to put a mathematical concept there, treat it as a physical object, and hope that you don't notice, that you don't realize that. Okay? No such thing as a wave packet. The wave packet says light is both a wave and a thing, a ball. And so, how do you reconcile those? In fact, the wave itself is made out of particles. That's what's moving up and down, a bunch of particles. So, the wave packet, draw it. Once you draw it or you illustrate it, then I know what you're talking about. If the wave packet is the mediator of light. And then you have other mathematicians that say, well, light does not need a mediator. So what is it that's traveling if you don't have a mediator? And so they turn it around. They twist it, twist the language. They twist the question around. They say, well, it doesn't need a medium through which to travel. What is traveling through a non-medium? What is it that is traveling? So space, assuming space is nothing, which it ain't in mathematical physics, but let's assume it's totally nothing, meaning there's nothing there, absolutely nothing, devoid of particles or whatever. And so they say, well, the photon or the wave packet or the wave can travel through nothing of space because it does not need a medium through which to travel. Yeah, that's got to do with space, with a medium. I'm saying, what is the medium that is traveling through nothing? Okay, and so the question is not that it doesn't need a medium through which to travel. The question is, what is the medium that is traveling, that's doing the traveling through nothing? Okay, so they twist all that around because they're, mental cases and they don't even understand what they're saying. That's the issue. Okay, they have particles at two places at once. Okay, famous, superposition and all these words that they invented out there. Then they have particle is not really a particle, it's a wave function. The wave function collapse, that's what a particle is. Okay, it's really a field excitation. That's what a particle is. The word particle means in mathematical physics. What is a field? It's a concept. That's what a field is. There's no physical object called field. Field is just a bunch of numbers. You can look up the word field yourself, and you'll find that it's just a bunch of numbers. Okay, decreasing strength as you leave or get farther away from ground zero. Okay, for whatever it is, gravity, electricity, magnetism. Accelerate a wave function or a field. Which one are you accelerating? Are you accelerating the concept field or are you accelerating the concept wave function when you accelerate a particle? Okay? So this is the issue. They're reifying all these concepts. Mathematics does that all the time. Particle can't produce pull. So even if you do have a particle, how do you produce pull with that particle? I mean, do whatever you want with your particle. Just take the particle and tell me how you pull with it. Negative momentum transfer. Is that how you're going to pull? Magical, just change the sign and say now change directions, which is an issue of physics, not an issue of math. Hume has no gravity. To this day, they cannot explain gravity at all, and they never will. You can't explain gravity with particles. So you have to do what? Negative momentum transfer. You got to turn it back into a mathematical nonsense instead of talking about physics. Energy transfer, what is that? How do you transfer energy? Move a mass, wave a wave, etc. And besides the wave, it's just a bunch of vectors. So whenever you see that transfer wave, all you're seeing is a bunch of moving vectors, which is another irrationality. What they're illustrating has nothing to do with the world of physics. It has to do with mathematics only. They move a charge, and then they have orbital as a region. And they say the orbital prevents the electron beam from flying out of the atom. How can it prevent it if an orbital is a region and a region is a constant? Okay, so this is the issue. They have all these irrationalities, okay, and they get away with all that. Okay, and so here it is. The last point that this fellow made: observation description. He talked about, and that's got nothing to do with science. In science, we don't gawk, observe, and we don't describe. You know, anybody can describe. I can describe a chair. Am I a scientist because of that? Am I a physicist because I described a chair and say, well, yeah, it's got a seat, a backrest, and four legs? Mathematics, right? I described it mathematically. Is that science because I described a chair? And so, yeah, observation and description have nothing at all to do with science. Science is explanation. That's where you have to break your brain. If you cannot break your brain explaining something, then we have a problem. Okay, then we know that you are not a scientist, meaning you are not a physicist. Okay, so let's move on here. Uh, we had um, we had these people known as flat earthers. Okay, and let's do a little bit of a rundown on what the issue was. It had to do with the flat earthers not understanding what gravity is. Essentially, that's what it comes down to. Okay, so here's flat Earth and gravity. Okay, and they say it's density, they say it's inertia, and they use all these concepts. And we don't want concepts. We want to know what physical object prevents an atom from moving. That's essentially the issue. So let's start at square zero. Okay, we're going to go with a first frame of the film. Okay, here it is. We have a van, okay, and we have a particle. We're going to call that an oxygen atom, or we can call it a molecule. I'll use the word molecule, okay. So that red little dot there, that's a molecule of air. Okay, think of it as that, as a single particle, period. Okay, so we have the van and it's standing still, it's parked, okay, and now this van is going to move, okay, so it's going to move, and the question, what happens to that particle? Turns out the particle stays in the same place, and the particles that are close to the back of the van, those are going to be pushed by the back of the van. But that particle, the one that's still up front, that particle is not moving. So when the van moves, okay, the particle stays. You see what happened there? Okay, let me do that again. Here's the particle, okay, just watch the particle and you watch that. As the van accelerates, the particle stays in place. We got that so far? Okay. Uh, Flat earthers, all these people, they have a lot of problems with that. Okay. So it stays in place. And the question is, what caused it to stay in place? And here we are 6 weeks later, and still they can't understand the question. They can't understand the question. Obviously, they won't have an answer, right? Okay, so here we have it. Gall says, these are some of the answers I got. It shows you that they don't understand the question. And I like this fellow. Yeah, he went in there and he says, I went to school. Okay, that's great. I'm glad you told us that, okay, that you went to school. Apparently, he went to a $30,000 a year Royal Naval private boarding school. My God. Okay, he must be a genius. Okay. And this flat earther says the space in between those balls are a deceptive misnomer. Non physical empty spaces have never been physically proven to exist. He's saying that space does not exist. There's no separation between objects. It's object against object. That's what he thinks it is. Ball against ball, cube against cube, whatever. Empty space is literally nonsense. And this guy went to what? He went to school, okay, and $30,000 a year Royal Navy private boarding school. All I can say is, please, guy, go sue that school and tell them that they gypped you. They took away, your money for. At least try to recover, your whatever money you invested in there. They are only a mathematical construct of the perfect vacuum of space. You are touting non physical pseudoscience concepts which have never been experimentally verified, even with the best vacuum chamber on Earth. So this poor little fellow, he believes that you have to prove the existence of space, otherwise it doesn't exist. And again, it has to do with all these people who talk about proof, evidence, experiments, testing, verifying. None of that has anything to do with science. In science, we do not test, we do not do experiments, we do not verify anything. Okay, in science, we explain. You have to get in the ring, be a boxer. You have to fight. You're not the critic who's sitting in the audience and saying, well, you should have hit him with a left hand and with a right hand and whatever. No, the way it works in science, you have to be a boxer. That's a scientist, the guy who's up there in the ring putting forth a theory and defending it. Okay, and so this guy talks about verifying. That's religion. Verifying is religion. Evidence is religion. Evidence is what a prosecutor uses to persuade the jury. That's called evidence, and that's got to do with persuading, which has nothing to do with science at all. It's got to do with religion. We do not prove in science, especially we don't not prove the existence of space. Good luck with that one. Okay, prove the existence of nothing. Yeah, it's easy. Okay, so what is the issue? Well, he says you are avoiding the fact that there is no gap between the molecules in reality. There are molecules throughout. Like the structure of the atmosphere. Unless you can explain what your gaps are, why the molecules are not already touching each other, they are composited from various sized molecules, which you are completely avoiding. Okay? Says, I have only ever been dealing with 100% physics of molecules touching molecules in a fluid sense and then touching a physical structure of glass molecules. Okay, structure of a physical car and structure of physical molecules of the atmosphere is the only mechanism available to you in reality. He's talking about the fact that the car pushes the molecules and the molecules, are all pushing on each other. So he's saying that the molecule is really that I'm talking about, the one that I'm saying stand still. He says it stands still because it's got all these molecules not only underneath it, but all around it that keep it in place. That's what holds it in place. That's what he's referring to, okay? If you deconstruct the atmosphere, adding gaps everywhere, then there would be an immediately automatic adjustment to fill those imaginary gaps you added with molecules. It's like swimming in a ball pit with various sized balls, and the big ones and small ones all support each other. So this fellow says there's no such thing as space. Okay, that he's got this notion that they had in the old days, in the days of the Greeks, where as soon as you had Aristotle believed in that as well. That if you move a molecule, another one takes its place immediately. So there is no such thing as space because it doesn't allow for there to be a space. As soon as one moves, another one takes its place. It could be an oxygen molecule, could be a water molecule, could be a molecule of a table or whatever object, immediately takes that space. So there's no such thing as empty space according to this fellow, which was what Aristotle said a long time ago. Okay, this is what he's got. He's resuscitated poor old Aristotle. Okay, so let's zoom in, okay, on that little picture he had there, okay? And there you see the molecules. We're going to consider them as perfectly round, okay? They're not even that, okay? But assuming they're round, we want to know what the white stuff is, okay? What is that white stuff that separates one molecule, that contours each molecule, each atom, if you will? What is the white stuff? That's the $1,000,000 question. If you say there is no such thing as space, which serves as a backdrop to every single object in the universe, tell me what does. What do you call that thing that separates table from chair? or molecule from molecule, or atom from atom. What is that stuff? What is the white stuff? That's what we wish to understand. We want you to identify the white stuff. Okay? And so if you have cubes, same thing. I mean, you might say, well, they're face to face, they're surface to surface. You got to tell me what separates each cube. Otherwise, that would be a single block of, of matter. The universe would be a single block. Okay, so hopefully, if you have little particles and they're squarish like that, cubic-like, well, then you have to tell me what separates one cube from another. If not space, what is that stuff that separates one cube from another? You have to identify that. And this fellow doesn't believe in space, but he doesn't tell us what he proposes instead. Okay, that's where we have a problem. Okay, but he continues and he says the following. He says, what is making a single oxygen molecule stay in location until the window hits it and drags it along? Yeah, that's the question. We want to understand that question. Do you understand the question? And he doesn't, because he has the structure of the atmosphere. Okay, let's see what he's got in mind. There are other molecules radially in all directions providing resistance and support to this single isolated molecule. So he says the molecule is surrounded by gazillions of molecules. So if this is the molecule, right, he's got all these molecules all around it that hold it in place. That's what he's saying, okay, more or less, because obviously there is some motion, but in general it doesn't move as fast as the molecules which are hit by the glass in the back of the van. Those molecules are moving faster because suddenly the car hit them or struck them or came up against them. The molecules that still have not been touched by the glass, they're standing still right now, and he's saying they're held together, held in place, in that place, by all the other molecules in the car. That's what he's saying. Okay, keep that in mind. Without a structure of the atmosphere with molecules surrounding this isolated molecule, it would naturally fall down, as it would have no supportive medium of an equal or greater density beneath it. Okay, he's talking about beneath. He hasn't mentioned anything about the side. And then he makes it even worse for himself. He says, 5 weeks of me repeating the exact same thing. Yeah, this is now the 6th week, and still he hasn't understood the question. Let me show you what the problem is with him understanding the question. If Eddie says, as he's saying, that the molecule of air, right, or atom of oxygen, it doesn't really matter, is being held by all the other molecules of air, okay, well, then we would have this situation, and I only drew a few of them there, okay? It would be held together in place, like he says, by all the ones that are sitting on the bottom of the van and those that are hitting already in contact with the back of the van. So these molecules are not sitting exactly standing still. They're all moving around, but relatively in their own region. Okay, they're not moving widely in the van until the van accelerates. Okay, now we're going to accelerate the van, but see if they're all these molecules are what hold the red molecule in place. Then when the van moves, it's going to take them with them, all of them. It's going to take the red molecule as well if it's like he says that all these molecules hold it in place. It's the same situation that I had the other day with the pencil. If you put a pencil, because it's solid, well, yeah, the van's going to push the whole pencil, every molecule of the pencil. And here we have the same situation. Here you have it standing still. He's saying the molecules are holding it in place. And when the van moves, it should move all the molecules at the same time. This is not what is happening. Okay? This is not what is happening. What is happening is that that molecule stays in place while the other molecules are moving. What is happening is this. Let me show it to you. Okay, this is what is happening. Okay, let's see it in motion here. Okay, here we have a tree. Okay, and we have the van moving all the atoms at the same time. This is what he's saying, that the molecule is being held in place by all the other molecules. Well, then they should all move together, and this is not what we see. What we see is that little red molecule stays in place while the others are moving. What we see is this, essentially. Here it is, okay? you see that it's moving one group of molecules at a time while the others stay in their place. Okay, you see what's happening here? It's not that they all move at the same time, all the molecules of air. No, some are moving while the other ones are standing still. And here, let me freeze one frame so that I can make my point. This is what we're seeing. Okay, we're seeing that a molecule, the van is pushing the molecules in the back to which it's in contact with, okay? And those are moving the other molecules. But meanwhile, you have all these other molecules which are more or less standing still in the same region, waiting for something to push them forward. Okay, that's the situation. And this fellow doesn't understand that. He says, oh, the molecules are held in place by all the other molecules. Well, if that were the case, then they would all move, as a single group. Okay, and that's not what we see, or that's not the theory, at least. He might have a different theory. He's got to put it out there. Okay, so this is the issue. Okay, so let's go slowly here, Here we have a fellow who says, just added that, says, whoever said the air in the car was standing still, everything on the planet is moving at hundreds of thousands of miles per hour with respect to the center of the galaxy. Motion is always relative. Again, this guy is completely out of whack. He doesn't understand what the context is. The context is all molecules are moving. No one is saying that they stand completely still, especially air. Okay, so they're moving, but some molecules are moving faster than other molecules. Why? Because the van is pushing those molecules, and those molecules are pushing others and others and others down the line as the van accelerates. But until the van pushes the molecules which push the other molecules, some molecules are standing still waiting for the other molecules to be squashed together and push them forward. That's what's happening. Meanwhile, these molecules are more or less standing still in the same region, waiting for something to push them. This is what these people don't understand. So we got to go very slowly here, because they 6 weeks, they still don't understand the question. They don't understand what they're supposed to answer. And obviously, if they don't understand what they're supposed to answer, they can't answer the question, which explains in large measure why no one has been able to explain gravity in mathematical physics. Oh, these are flat earthers, all of them, from mathematical physics all the way to the last guy in the flat world. Okay, so here it is. Let's go slowly. What did I do the other day? I think a couple of weeks ago. We have a tree, and we built the van on top of the tree by mistake, by design. We don't care. Okay, the point is, we built the van, or the van is parked on top of a tree somehow. The tree grew underneath it. Okay, that's the situation. So the tree is stuck to the ground, whereas the molecule of air is not stuck to the ground. Neither one is touching the van. Neither the tree is touching the van, any part of the van, neither the molecule. The only difference between the molecule, I mean, they're both inside the van, but the difference between the molecule and the tree is the tree is stuck to the ground, obviously, whereas the molecule apparently is not. Okay, that's what we have in front of our eyes. Okay, we understand that so far? Now the van's going to accelerate. What's going to happen to the tree? What's going to happen to the molecule? Well, hopefully the tree remains behind, right? But does the molecule remain behind? The answer is yes, the molecule also remains behind. Here it is. Okay? So here it is again. Okay, this is where we were. And now the van moves forward, the tree stays behind, and the molecule stays behind. So we asked the people, we said, well, why did the tree stay behind? And people say, well, because it's stuck to the ground. That's why. It's not touching any part of the car, but it stayed behind because it's stuck to the ground. Okay, so we all pretty much understand that, right? The question is, why did the molecule stay behind? What is it stuck to? And here people say, well, the issue here is that there is no force that came up against the molecule. That was not the answer they gave to the tree. They didn't say there's no force that pushed the tree. They say the tree is stuck to the ground. That's why it didn't move. They didn't talk about force there. But now they're saying a force did not touch the molecule. That's the answer they give you. Everybody gives you that answer. The first problem is the word force is not a physical object. Okay, so you can't say that a force did not push or pull on the molecule. You can say a horse did. Maybe that's what they meant. You can say a horse did not push on the molecule or pull on the molecule. You can say a car, a tree, a chair, a rock. You can say any of those physical objects did not push the molecule, but you cannot say a force because a force is a concept. Okay, so the people who fed them this language, force, were the mathematicians, and that's the language these people use to try to communicate their ideas. And so they say a force did not move it. Okay, so we can't say a force. You can say that a paddle did not hit that molecule. Then we all understand it. Okay, paddle is a physical object. Okay, so we have that situation where the tree stays behind, the molecule also stayed behind. You say, well, I understand why. The reason it's stayed behind is the tree is stuck to the ground, the molecule is not. No force came and pushed the molecule. That's the answer they give you. Okay, let's do it differently. Let's do the experiment a little differently so that we get to the bottom of this thing. Little by little, 7 weeks, 8 weeks, we'll get to the bottom of this. Okay, so here we're going to build the van this time on top of a different kind of tree. The tree is just lying down there, or maybe the van just parked there on top of the tree. Okay, so that's the situation. It just parked there. So we have the tree, and it's not stuck to the ground now. It's also inside the van, most of it, like the particle is. What's going to happen when we accelerate the van? What's going to happen to the tree, which is no longer stuck to the ground? What's going to happen to the particle, which is not apparently stuck to the ground? Okay, that's what we want to find out. Well, more or less, this is what probably is going to happen. The van is going to advance, and the tree is also going to remain behind together with a molecule. And so now, why did the tree stay behind? And you can't say it's because it's stuck to the ground. So what are you going to say? Are you going to say that no force moved the tree? Is that the answer you're going to give? There was no force until the van hit it. Until then, no force hit it. So is that why the tree did not move? See, before the answer was it stuck to the ground. Now the answer is, well, a force did not move the tree. What do you mean a force? What force kept it there? That's the question. And this is where people have a problem because they don't realize that you require a force to keep it there. Okay, just like you require a force to keep the molecule there. Both require something to keep it there. And that's something Newton and Galileo and all these other people never discovered. They said, well, a particle moves or a thing moves, a mass moves, right? As long as something doesn't stop it or changes its course. That was the idea that they had. Well, what about something standing still? Doesn't require something, a physical entity, to keep it there until a force, a horse, right, moves it, until a thing comes in contact with it and moves it. Don't you require something to keep it there? Yeah, it's known as gravity. See, it's gravity that kept the tree there underneath the car. When the car moved, it's gravity, whatever gravity is, right? Density, mass, inertia, whatever word you want to put in there. That's what kept it there. That's what kept the tree there. And it's the same thing that keeps the molecule there, even if it was the only molecule in the entire car. Okay, so we have the molecule and we have the tree, and they're all both standing there because something known as gravity, inertia, whatever you want to call it, kept it there. What we need to answer is, what is gravity? What is inertia? What physical thing mediates gravity? That's the question that you have to answer. And people say, well, no, until a force hits it. No, forget about that. We don't care about that. We want to know what kept it there. And you can't say a force kept it there. The force of gravity. because that's what we want to answer. We want to say, what is the force of gravity? What mediates the force of gravity that kept the tree and the molecule staying there until the van hit them and moved them? That's the question. Okay. And so, yeah, we do have an answer. Obviously, here it is. It's that what keeps the molecule in place is that the molecule is bound to every atom on Earth. Every atom on Earth is bound to that molecule. So even though it has some movement, yes, it does move, it moves very little until the van accumulates all these particles and pushes them all forward when it accelerates. Okay? So the molecule is pretty much standing in the same region until something hits it. Why is it standing in the same region? Because it is bound to every atom on Earth. Every atom on Earth is bound to it. And you say, Bill, that's nonsense. I don't see anything. So there's nothing there. What do you mean it's bound to every atom on Earth? And once again, I got to pull Mr. Muller out. Professor Muller from Berkeley, and people may be sick of hearing him, but I'm going to put him one more time because all these people are so ignorant that they are not listening again. They should listen to Mr. Muller. Here he goes. Listen carefully, okay? Here he goes.
What's the force of gravity on me? It's the pull of the Earth on my body. So, for example, if you have the Earth with its big mass here, and you have you with your little mass here, that every atom on the Earth is pulling on every atom of you. You're also pulling on it.
Okay? So you're pulling on it, and everything is pulling on you. Did you understand that? Apparently some people still don't understand what that, and I know people don't understand because no one even raised the issue. Here I'm putting that on there. Nobody commented on that. Not a single flat earther. See, if they would have commented and say, look, I don't agree, or for this and this and reason, they made a case. No one even addressed the issue. So I put it on there. They're listening to it, but it's like everybody skirts it, goes around it, goes way around it. They don't want to address that issue. And so all I can do is show you one more time. Tonight, when you go to bed, please say the Lord's Prayer, the Lord Bill's Prayer. Okay, here it is. Every atom on earth is pulling on every atom of you. You are also pulling on it. The amazing thing about gravity is that it goes right through things. Okay, if you can understand that, you have understood gravity, the cause of gravity. And the other thing that you've got to understand about that is that since we can't see or touch whatever is connecting you to every atom on Earth, then you have to conclude that the mediator is invisible and intangible. It's known as noumena. You have phenomena and noumena. Noumena are things that are of the mind. You can only visualize them. You can conceptualize them. Say, look, this is probably how Mother Nature does her things with invisible, intangible things, things that we cannot see or touch. But that's the way we can explain gravity. Otherwise, you have to say action at a distance, and that is known as black magic. Okay. Okay, so let's go on with some of the questions, comments people made. Here we go. You stated a wave moves in only one direction. Absolutely, yeah. You show a surfer riding on an ocean wave and say the wave only pushes. Okay. I live at the beach and can see water being pulled out. When catching a wave, I can feel my body being pulled by the water towards the wave. No kidding. Is that so? Question, is my experience that a wave pushes and pulls an illusion? Fellow took this completely out of context, okay? That's what it is. He doesn't even realize that, okay? And yeah, waves Waterways, waterways. Okay, we weren't talking about waterways. That was an example, just an analogy. Okay, showing that the wave pushes the surfer towards the beach. Does a wave pull backward? Yeah, of course it does. Okay, but we're talking about something else. And again, he took it out of context, and so he gets 10 minus points there. Okay, here it is. Okay, the context is gravity and light transverse waves. Okay, we're talking about transverse waves. Do you know what those are, fella? Not ocean water waves, because those push and pull. But what are space-time waves? How do they pull? How do they even push? Okay, transverse or longitudinal. Which ones are they? Here you have on the right-hand side, upper right-hand side there. Transverse waves are slow, and longitudinal waves are fast. Okay, they're faster than transverse waves, which are the worst kind of waves to simulate light with. And today we're simulating them with transverse waves. And there at the bottom you see a comparison. You have longitudinal waves, which are like sound. Okay, and those are faster than transverse waves, but that's just the least of their problems. Anyone proposing transverse waves doesn't realize that what you're staring at is vectors, mathematical vectors. What are vectors? They are just arrows that represent magnitude and direction. Okay, and yeah, there you have two black holes. They're colliding. Okay, and this was confirmed by the mathematicians a couple years ago. They won a Nobel Prize for saying, look, when two black holes collide, they send all these waves outwards. Well, what kind of waves are we talking about? I mean, if they're going outwards, how do they pull? I mean, if the wave comes outwards along space-time, how does that pull on you? That's the question they have to answer. Okay, and then how fast do they travel? I mean, if they're transverse wave, they travel slower than longitudinal waves, which travel much, much slower, both of them, than torsion waves. Okay, so torsion waves is the fastest wave that man uh, has experience with. Okay, and torsion waves moves along a mediator such as a rope. Okay, here's my rope. Okay, torsion wave, not only is fast, but it goes along a mediator, rope-like mediator, DNA-like mediator. What does a transverse wave move through? And they say, well, it doesn't need a mediator to move through, but that's space. What is the thing that's moving? What mediates light itself? Okay, that's the question these people have to answer. And they get confused and they talk about the mediator through which it's traveling. It's like saying fish travels through the ocean, but a fish doesn't need an ocean through which to travel. Great, no problem. So fish can travel through space, empty space, nothing, no problem. But you have a fish. You have to have a fish in order to have travel. And so the question is, what is the fish in the case of the photon, in the case of light? That's what you have to identify. And to say nothing is traveling, well, nothing has a difficult time traveling. You have to identify the object there that's traveling. Okay, and then it's just to make sure we rub it in. Okay, here it is. Longitudinal seismic waves reach you 1.7 times faster than transverse waves. And you can see why. The transverse wave has to go up and down where the other one just moves along an axis. Okay, so that's the reason longitudinal waves travel faster. That means that sound should travel faster than light if light is a transverse wave. Okay, so bad way of simulating, the worst way to simulate light is with transverse waves. Okay, it's the slowest wave known to man, and the fastest one is torsion. Okay, torsion doesn't move anywhere; it just twirls in place. It's in the same place. It's just in situ. Okay, so here you see the traveling wave. What is it? A bunch of vectors. Okay, that's what you're staring at. Magnitudes and directions. So this is surrealistic. Okay, they have all these arrows, Indian arrows that represent magnitude and direction. They're moving. It's a mathematical contraption. They call it a mathematical object or whatever they call it. What you're looking at is nonsense. That's nonsense. They try to illustrate a mathematical concept. That's what they did. Again, they reified a mathematical concept. And it's irrational anyways, because you're talking about magnitude and direction, and a bunch of them, and they're moving. No, a torsion is a rope. It's a thing, okay? So you're talking about a rope, DNA-like rope, pair of twine threads, and it's torquing. We're done. That's how easy it is. That's how fast it is. There you see it, okay? Much faster than a traveling transverse wave. Okay, and what was the context? The context with this, you had the Earth flying out of the solar system if the sun were to disappear. And here you're going to see the waves coming out of the sun when the sun disappears along space time. So, how fast do they move? Are they moving in one direction? If they move in one direction, how do they pull? I mean, if they're gravitational waves, how do those waves pull? And again, they have this outward going thing moving along space-time, which moves constantly because all those waves are being created constantly by the sun, even when it is there. So the oscillations along wave space-time are there anyways. Okay, so if they move in only one direction. How does a wave that moves outward pull inwards? That's one issue. How fast do they travel? And then how does it keep, the Earth from flying out before it disappears? Okay, so too many problems with the gravitational waves of general relativity. Einstein didn't believe in them, by the way. He wrote a paper against those. Okay, and here you have another fellow says, you state that the speed of light is constant. Yeah, absolutely. Since Albert always travels at c, little c, okay? Since Albert, meaning Einstein, proposed this, didn't physicists start taking measurements and come up with different speeds? Idiots did. Okay, they're known as idiots. Yeah, not physicists. I was told the speed of light became constant for the equations to work. Uh, Actually, it's the other way around. Little c is used by general relativity, but general relativity uses warp space. And when you have, the little photon traveling along a curved surface, in other words, it's curving, what you have is angular momentum. Angular momentum has to increase the velocity. And what they've done is just change the direction and keep the velocity constant. So it's cheating. Actually, if space-time is curved, like they say, light would have to travel faster and faster and faster if it's going in an angular momentum direction, if it's changing its direction. Okay, but the way they cheat, the mathematicians, they bring the physics part, which is direction, and that's what they introduce into angular momentum and say, well, you don't have to increase the speed because what you're really doing is just changing the direction. So the speed, in other words, the velocity is the same, but what changes is the direction. Direction is a physical concept. Velocity is a mathematical concept. Speed and velocity are mathematical. Okay, and that's what they do. They cheat. Okay, so a mathematical solution was devised. I got to say something about that. The measurement was fixed by distance traveled in a vacuum. Could you explain or clarify? Yeah, I can clarify very easily. There you have it. You have a given set length of rope. You can call it a meter, whatever you got there. And if you torque it more and more and more and more, well, you have more or less the same amount of rope. Okay, and that's a long story to explain why it's almost the same. But you have more links, right? Frequency, and each link is shorter wavelength. Okay, so with a rope, you can explain frequency in exchange for wavelength. Why c equals frequency times wavelength is a constant. Little c is 300,000 kilometers per second. It's a constant, and it's a trade-off between frequency and wavelength. And there you can see why with a rope. The rope is the only thing that's imaginable that can simulate, can model c equals frequency times wavelength, which has been amply verified. And here you have it. The more you torque this rope, the shorter are the links and the more links you have. More links, frequency. Shorter links, wavelength. We're done. See how easy it was? But we get a bonus on that, and that is that you get this as well. You get that, why Einstein concluded, rightfully so, that the velocity of light is independent of the movement of the source. If you turn your light on while on a train, you don't add the velocity of the train to the velocity of light. the velocity of light remains 300,000 kilometers per second, whether the train moves, stands still, or moves at close to the velocity of light. It doesn't matter. The train can move as fast as it wants. You do not add the velocity to your flashlight. And you say, how can that possibly be so? Physically, from a physical standpoint, how can you explain that? You would think that, like if you throw a ball while you're on a train, yes, the ball, you have to add the velocity of the ball to the velocity of the train. That's not the case with light. How do you explain that from a physical point of view? And here's the answer. The answer is very clear. The rope is made of the same material as the atoms. And what the atoms do, they slide along the rope while eating up the rope. So if an atom approaches another one, like you can say that's the train atom or the flashlight atom, the one that's moving there, it doesn't add to the velocity, to the torsion on the rope, which is always at the same tension, which is always little c, 300,000 kilometers per second. What you're doing essentially is moving the atom along the rope, and it's eating the links as it moves towards the other atom. That's what's happening. So no, you do not add the velocity of light to the velocity of your flashlight. In this case, the atom there represents an atom of a flashlight. Um, what it is, it just slides along all the ropes that are everywhere around us. Invisible, intangible ropes. No, it's not a concept. A rope is a physical object. It's a noumena, in other words, noumenon, meaning it's not a phenomenon. Phenomenon means visible stuff. Noumenon are invisible stuff that you can only conceptualize. It's a mind object. You have to visualize it. It's the only way to conceptualize gravity. Otherwise, you won't have any success at all. Okay, and here's another fellow. He says, does rational science now acknowledge the empirical observation of black holes? If yes, do they undermine the law of conservation of info and energy? I don't know what conservation of info and energy is. No such monsters in science. Okay, energy is a concept. We don't conserve it. We don't put it in a little bottle and have, keep it for later on. And same with information. You can't conserve it. Okay, I tried putting some information in a little bottle. Very difficult. Cosmology refers to an observation of the movement of galaxies towards a great attractor. Is this considered valid empirical physical information yet to be explained by a physics model? Well, again, black hole is not a thing. There's no such thing as a black hole. Okay? Why? Because as I explained in the past, black hole is zero-dimensional, proven by Mr. Chandrasekhar. He won the Nobel Prize for proving mathematically that a black hole has no size, no nothing. It's zero-dimensional. Okay? And so, there is no such thing as a black hole. Black hole, a thing is that which has shape. Black hole doesn't have shape. We're done. Science, we have no laws. So I don't know what this fellow is talking about when he says laws. We don't legislate. We don't have a legislature, a Congress, an assembly, nothing like that. Okay, so I don't know what he's talking about. Info energy are concepts, so we don't use those in science at all. They're irrational concepts, okay? Especially energy when they say they transfer it. When you begin to move energy, you know you're in trouble. It means you've had too much to drink. Physics does not conserve concepts, again, okay? No jars to conserve these concepts. And physics, we don't empiricize anything, and we don't gawk, okay? So those are the first answers to this fellow's questions, okay? Just to answer the main ones there, the structural ones, the foundational ones, okay? Okay, but here it is. This is how they discovered the so-called first black hole. And it's important to see how these people convert their opinions into science and say, oh, we've proven it. Okay? And here it is. Okay, this is the first black hole, Cygnus X1. This is how it was discovered in the 70s. I think 78, maybe 71. I can't remember now very well. Okay, but here it is. Okay, what they did, they inferred that there was an invisible black hole that was influenced Cygnus X1. What they said, they pointed their telescopes or whatever devices they had to this star out there, and they saw that it was moving. Okay, and it was moving like that, like in a circle, and they said, but there's nothing there. And so by hand, they put something in there, and they said there must be a mass. And so they put that mass in there, and they said, oh, there must be a black hole, and it's rotating around the black hole. And so we've proven that Cygnus X1 is a black hole. Okay, so that's how they proved it. They inferred it. They inferred it that there was an invisible object that they could not see or touch, right? And they said there is this thing, and they called a black hole. And because it's a black hole, it's got a lot of mass, and that mass is compelling this visible star to move in circles around it. Okay, so this is how they proved, okay, the existence of black hole. And they said, what else could it be? That was their reasoning. They said, what else could it be if not a mass out there and a star moving around this enormous, invisible, intangible mass? That was their whole reasoning. Okay, so how do we explain it? Okay, in rational science. Okay, same black hole. Okay, this is how we explain it. If you put a charged ball in a magnetic field, it's going to move in circles, gonna twirl around and spiral around. That's what it's gonna do. Okay, you can do this in a lab. Okay, and so I'm not going to show that, but just take my word for it. Put a ball in a magnetic field. It's gonna charge ball. Okay, it's going to go around and spiral around. Okay, if you concede that, you can look that up on your own. Okay, here you see it. That's what a black hole is. Here you have the galactic magnetic field. It's sweeping downwards, and there you see it on the upper left, the little ball going around in a magnetic field. That's exactly what's happening in the case of a black hole. It goes around and around nothing because there's the magnetic field of the entire galaxy that's sweeping down or up, it could be, right, in that region. That's what's happening to that star. Okay, so it's a magnetic phenomenon and has nothing at all to do with gravity. Okay, so that's the first issue, but we got to clarify something else, and that is that a black hole is alleged also to suck the gases from a star, neighboring star. Okay, they claim to have observed that, and here you can see an image here. You have the star. Suddenly, its gases are sucked into nowhere, and it turns out it's sucked by a black hole. That's what they say. They don't see the black hole, but they see the stuff coming out of that star, all that mass and all that gas, and it's going somewhere. It's going where? It's going to the black hole. That's what they say. They don't see the black hole, but they say it's going somewhere, and they say it's a mass that it's attracting it, and we call that mass a black hole. Okay, so that's their inference. Okay, again, okay, here it is. One more time. If you have smoke in a little lab, okay, just like we showed, the little charged ball going around in spiral. Now we're going to see smoke being captured by a magnetic field, what is known as a magnetic field. Here it is. Okay, you can see the smoke, and a magnetic field is drawing all that smoke in, it's swallowing it up. And that's what we're saying is happening in the case of the star. Here is the smoke on the bottom right, okay, being sucked by the magnetic field. And there you see the other smoke, okay, the gases of a star being sucked by a alleged black hole. What it is really the magnetic field of the galaxy sucking the gases from that star. So the gases, so the magnetic field is doing both things. It can suck the gases out of a star, and it can also compel it to move around nothing, because that's what a magnetic field does. Has nothing at all to do with gravity. So we're saying it's a magnetic phenomenon. Now, just to show you another possibility, okay, we like to show this as well. Could be two galaxies, neighboring galaxies, and the star that's being affected is being pummeled by the magnetic field, the threads, that are going around the galaxy, because these are magnetic threads, as we call them. These threads are sweeping down on these so-called black holes, on these regions where they see star moving around nothing or a star losing its gases. And we're saying the confluence of two um, magnetic fields of two galaxies. That could also be the case, and that's why they're singled out as stars that move around nothing and that are losing gases. Okay, so these are possibilities that you got to consider. You got to ponder them under the rope model. Okay, another question, comment people say, stars are made mainly of condensed matter, thus it is uncollapsible. So they're saying stars cannot collapse because they're, I guess, made out of a single piece. That's essentially what this fellow is saying or suggesting. And so here we take the view of the establishment. Okay, we agree with the establishment. A star, if you were to go to the center of a star, you would see tremendous reactions. Okay, in there, in the center. Okay, it's fusion going on in there. Okay, but what you see there, this is the official version, and that you see that atoms are traveling at great speeds and they're hitting each other, striking other atoms at great speeds. And what you're talking about is maybe hydrogen atoms, four hydrogen atoms, and they're traveling at such great speeds that they fuse to form helium. And so that's what a sun does in the center. It turns four hydrogen atoms into helium and it releases the excess energy. That's the official version. Okay? And here you see a diagram of that. You know, you can see the center of the sun, okay? And this is the same for any star. And what you see is four hydrogen atoms there at your left side, and they collide and they turn into two hydrogen atoms. Together with one hydrogen atom, they form this 3H helium, okay, three helium, and the heliums then combine to form this helium molecule, the four helium, where it kicks out on the other side. You know, they kicks out hydrogen, two hydrogen atoms. Okay, so if you do the math of this, it comes out right. But what they're saying essentially that four hydrogen atoms fuse at great speeds to form a helium atom. We have a problem with not with the fact that it's a fusion process. That we totally agree. It's a fusion process that's going on inside the sun. That's why the sun is almost eternal, 5 billion more years, they say, they calculated. That part we have no problem with. We have a problem with speed. Okay? We have a problem with velocity. We're saying that the atoms hardly move at all in the center of the atom. They are being compressed together. Okay? So here's the quantum version, essentially. Okay? This is what they're saying, that as the star collapses on itself, which this guy doesn't believe in, okay, the atoms are still moving at great speeds. Okay, and what they're doing is colliding against each other and forming helium. We say something totally different. We say this is what's happening. It's being compressed into helium. So when you go into the center of the sun, you will not find too much motion. Okay? What these atoms are doing is just being compressed, squashed together. So there is no such thing as speed. The fusion process inside the sun is a question of squashing atoms together, not one of velocity or speed. And the other thing we need to mention here is that we cannot reproduce this here on Earth because we don't have the pressures necessary to simulate what's going on inside the center of the sun. Okay, so this is the issue. We have no way of reproducing pressure here on Earth. What they can do is accelerate particles, which they do on their colliders, if they're really accelerating particles, right? Making them collide at great speeds, and they say, oh, if you make them collide, yeah, we can build helium from hydrogen. And that's the theory they have for the sun. And again, the only thing I want to mention is the official version is speed. You have acceleration of these hydrogen atoms. Four of them fuse through speed to form a helium atom. We're saying that's not what's happening. What's happening is they're being squashed together because there's hardly any room in the center of the sun. all these atoms just keep compressing, and the guy who's stuck in the middle gets 4 atoms get converted into helium, and the energy that's released is threads that are coming out. Thread is coming out at great um, what is it? Frequency. In other words, many threads or many ropes, many links of rope are coming out. Okay, so what it is, the squashing triggers the rope to shorten the links, and these links are high frequency, and that's what comes out of the sun eventually to the earth. Okay, so it's along the ropes. All we're doing is increasing the frequency on the ropes when we squash the atoms. Okay, and here we have action at a distance. Seems to me as a mistake from an experiment, a misconception, silly mistake. Well, we have to look at the cause of action at a distance. Where did they come up with this? The causes of action at a distance. And here I'm giving you an idea. Okay, they have to do a lot with the fact that they never defined the words properly. Okay, and so these are some of the causes that I came out of the top of my head. Irrational definition of the word object. Okay, that's where it all starts. Because if you think that it's see touch, well then you got the wrong definition. You got an irrational definition. Not all objects can be seen. Not all objects can be touched. On the other hand, all objects have shape. So obviously the universal property is shape and not see touch. And so the rational definition is um, that which has shape. And that means that you not necessarily will be able to see or touch an object, okay? And that means that action at a distance is simply a case where you have an object that you cannot see or touch, not one that is not there. That's the difference, okay? Because these people say, well, I can't see it and touch it, so it's not there. That's the wrong conclusion. It's an irrational conclusion based on the wrong definition, irrational definition. Okay, the other issue is that the irrational definition of science. Okay, they say it's got to do with experiment and observation, and you cannot experiment or observe that which you cannot see or touch. Period. We're done. Okay, so that's another irrational definition of science or the scientific method. Okay, um, if we assume that there is no mediator, you're doing black magic. Okay, you're pinching, voodoo dolls and affecting someone at long distance. That's what you're doing. It's called black magic. Okay, mathematics is the movement of concepts. So how do they mediate those? With the movement of concepts. So they say it's a field, it's energy, it's mass. None of those are physical objects. So you can't say that's a physical interpretation of why this object affects that one from a distance. Remote control. And finally, you have words like field, wave, time, energy, all those words. Those are concepts. And so when you have the movement of concepts, what you have is black magic. Okay, that's what mathematical physics is all about. Black magic. They call it philosophy when they can't answer the questions. Okay, with that, we'll see you next Sunday, and hopefully I can get my son Hans, and we're going to be there together. We'll see you then.